Welcome. Today we are going to discuss about simulating regression models, and courtesy is to Professor Asad Zaman. You can see more details asadzaman.net. So we have today consumption per capita in so if you paste it in Excel to B2 to B11 and GNP per capita C2 to C11. We have only picked 10 years data so that you are not lost in data. We have linear Keynesian consumption function. CT is a function of income. In practice, we don't know the value of A and B. But here, when we'll do simulation, we assume that we know the values of the parameters. So how we are going to run this simulation? What is simulation? Simulation is generating data artificially, but it resembles original data very closely. So when we regress this consumption on income, I'll show you in Excel how do we carry it. Okay, if I share my screen of Excel. So I'm going to share my screen of Excel and I'm going to rub all this for better understanding and to do it again. So here you have consumption and income. I am going to regress consumption and income equal to linearest. Okay, linear estimation. I am going to regress CT. So I have named variables instead of driving it. True means that you should have other statistics available. If you can take more statistics here up to this. Okay, and when you have this function, this is array function, you must have you must press Control Shift Enter instead of Enter. So now you have C hat. What is C hat? C hat is simply equal to H dollar. This is basically we need to press $sign, or you can name it. Okay, this is your fixed value. So $H $2 plus G2 times YT. That's your C hat. That's your C hat. And if you click here and you see here FX, you will get all statistics. 139.40 is your standard error of regression. So here we use C simulated. This C sim is equal to C hat plus standard error of regression, because we want to generate consumption in a similar way as its actual consumption. So we have variation. You can 139.40, or you can give the cell reference times. We need to generate it randomly. So therefore, what do we do here? We should generate random numbers. We should multiply here normal random numbers. So I'm going to multiply it as norm in Excel. Previous version, it may be norms inverse. Here you have norms inverse. This is just like looking at Z values for a given probability. So RAND will generate values between 0 and 1, and norm S inverse will look the value of Z against that given probability. So you will see here these values will keep on varying. No, and these are your simulated values, which are just like real values. So you see values are changing of simulation. So if you do any change in Excel spreadsheet, these values will change. No, unlike when we regress the CT and YT, whenever now you will regress C and YT, you will get a different value of slope. You will get a different value of intercept. So if I run here equal to, you can do it slope and intercept here equal to slope and equal to intercept commands, but I am using here C simulated values on fixed income. Fine. Now you will have a different value of intercept and slope every time. This is your the average consumption. This is your intercept. So you see sometimes it exceeds 1. You can in R programming, I will show you how you can constrain it less than 1. So every time you are doing any change here, you get a different value. So this is simulation. I'm noting it. Okay. Now if I plot consumption and income, and simulated value, Alt and D will give you scatter plot, and you can have slight modification in your x-axis. In bar chart, we don't have this permission to start it other than 0, but here we have. So this is now I put simulated data here. You'll see it will be like real data. It will very closely resemble to blue points, but it will not be exactly equal to. Now look here at this plot. Okay. Every time we generate a different value of simulation, we generate it, we regress it on y. Each time we have a different intercept, we have a different slope. No. To get the idea, what is the variation in this modular propensity to consume, what is confidence interval associated with it? One thing is, if you know the exact sampling theory, if you know asymptotic theory, so it's okay, you can associate standard errors as a standard theory. But if you don't know, if you have small sample, then what you will do? You will do simulation. So I am going to simulate this slope coefficient a large number of times. Okay, let's go. I do it, let's say 200 times. I do it 200 times. You can do it in R and other softwares with a very little programming. And now I go to data. What if data table, leave first as it is, and now there is a magic. Look here. Okay, oh, something wrong went with this. I do it only for this one. What if data, here you will have input cell, can't change part of a data table. Let's see what's wrong with this. I do it again. So here you have equal to, let's say I do this job in cell, equal to slope is this one, fine. And I'm going to, you see, every time I do any change, I just want to do it first of all only for 20 values. I would like to see why it's not showing the results. Okay, I am taking it as data table. That's it, that's okay. Now you see, every time I have generated 10 values, this one, I have regressed it on YT. Every time I get one slope value, and I have done this process again. I have done this process again. So I can have done this process. Okay, now you got it 20 times. Let's try it for 200 times. Maybe this time we get correct results. Okay, what if data table, and I leave it first one blank. That's it. Now you just copy it, paste it as special, because otherwise these values will keep on changing, so you will not be in a position to sort it. Let's sort it. So you see, now you have 200 values, you can have 2000 values, you can have 5% values bottom and top if it is two-sided. So you can discard those values, 2.5% from low, 2.5% from above. So 205% means 10 values. So let's discard first 5 values, so 0.53, and from above let's discard, okay, there is some you see we haven't put a constraint here. So we'll say that MPC though can't be more than 1. But here we say that this is 1.15. What we'll say that this 0.86 will remain between 0.53 and 1.15. That's your confidence interval. You can make its distribution. This distribution will look like normal. If you take average of these values, your individual value cannot be equal to this one. But if you take the value of these 200 values, average of these 200 values, that will be equal to O1, O200. That will be roughly equal to this 0.86. So that's what is the concept of unbiasedness. But my main objective was to show you that how to do simulation using Excel. I'll show you how to do it in R. Thank you for watching. Take care. Apna ख्याल रखिए.